Earthquakes and volcanoes are dramatic examples of the dynamic, changing surface of our planet. Violent earthquakes periodically remind us of the powerful natural forces coming from the Earth's interior.
Like earthquakes, volcanic eruptions are also the result of internal pressures in our planet and occur when molten rock explodes through cracks in the Earth's surface, sometimes with devastating results. When Mount St. Helens erupted in the state of Washington in 1980, trees were blown down more than 25 kilometers away. Huge mud flows swept the area, and the sky in much of the Northwest was blanketed with ash. Usually it takes millions of years to change the surface of the Earth. But through the unleashed fury of earthquakes and volcanoes, land can be transformed in minutes.
We'll start this program by explaining the theory of plate tectonics to see how and why the Earth's surface moves. Next, we'll look at earthquakes. Then, volcanoes. We'll study how mountains are formed and built by the Earth's dynamic crust. And then wind up by considering how the planet's surface may change in the future.
To understand how and why the Earth's surface moves, we need to look at the planet's internal structure. Several layers make up the Earth's interior. At the center lies the inner core, a revolving solid core of iron and nickel. Next, we have the outer core, which is liquid and also composed of iron and nickel. The entire core is about 3,400 kilometers thick. According to scientists, the core is fiery hot with temperatures of more than 6,600 degrees centigrade, or more than 1,000 degrees hotter than the surface of the sun.
Above the core, we have an area called the mantle. The top portion of the mantle is the asthenosphere, a 200 kilometers thick section made up of plastic-like rocks. At the Earth's surface is the crust. A lower section of the crust combines with the top part of the mantle to form a solid layer 100 kilometers thick called the lithosphere. Providing the surface foundation for oceans and continents, the lithosphere is divided into a dozen major sections, or plates, and several minor plates. The theory of plate tectonics concerns the formation and movement of these plates.
Scientists say that Earth's continents are like pieces from a giant jigsaw puzzle. 200 million years ago, they believe all the continents were connected in a huge landmass known as Pangaea. But over millions of years, Earth's surface plates have moved, resulting in the continents of Europe and Africa separating from North and South America. Arabia has separated from Africa, and India has moved north from Antarctica and collided with Asia.
According to scientists, the plates on the Earth's surface are continually moving. These huge sections of the planet's crust usually move very slowly, but nonetheless, they are in motion. As the result of this movement, when the plates collide, pull apart, or otherwise interact, there are adjustments at the boundaries. Friction, cracks, and weaknesses, often beneath the Earth's surface, can cause earthquakes, volcanoes, and mountain building. Plate boundaries, then, are danger lines for the furious energy that lies deep beneath our feet. In recent history, 95% of the world's earthquakes and volcanic eruptions have occurred in either of two areas: the Pacific Belt, which borders the Pacific Ocean, or the Mediterranean Belt, which extends from Italy and southern Europe through Greece and across Asia to Myanmar. Both these belts occur along plate lines.